In this video, we're going to look at how you can use LiDAR to estimate storage volume of a pond that you might be looking to create for NFM or other purposes. In this example, we're going to use 1 meter LiDAR because that's what most people have access to. But if you've got more higher resolution LiDAR or, for example, height data from a drone, then that would be better because obviously the more detailed your input data is, the more accurate you're going to get in terms of estimation of storage volumes. So, like I said, we've got the 1 meter LiDAR for an area, and I've also got a polyline showing where flow accumulation happens in this catchment. We have a previous video looking at how you generate that if you need to do that step first. So we're going to assume that you've been out on site and you've had a look around and identified a particular area that you think might work for a pond. And what we're going to do here is to calculate some rough volumes so you can see whether it would be worthwhile creating a pond in that location. So we're assuming that we've been out on site and we've identified this location. The first thing that you're going to do is to run the contour tool, which is in your spatial analyst toolbox. So you input your LiDAR, have an output named whatever you like. The contour interval is just the height difference between the contour lines. So I'm going to put in 20 centimeters, but you can change that depending on how steep or how flat your site is and how close together you need those contours. You can leave the defaults for the rest of these inputs. So in the environment, you just want to check that you've got your output coordinate system set to whichever one that you want to work in. So I've got mine set to British National Grid. I've also got my raster analysis set to minimum of inputs for the cell size, and I want to snap any rasters that generate to my original LiDAR data. You can leave the rest of the defaults as they are. So if you go ahead and run that tool, we have the contours that you can see have just popped up. Next, we're going to label them with their height. So in the expression, if you change that to contour and click apply, and then when you add the labels, you can see that the height data appears on all of those contour lines. So next we're going to have a think about where we want the extent of our pond. We're going to use the natural form of the landscape to do this. So I've chosen this area because it looks like we've got a flattish base and there's a slight natural constriction here that we could potentially place a bund across, and that would back water up into this whole area. In terms of a bund, you don't want it to be too high. So what I'm going to do is to make sure that for this example, the bund is only going to be about 1 meter high. So that would naturally constrain my choice as to which of these contours I'm going to use for the extent. So if I was to put my bund across here at this constriction, I'll just click to get the value of the raster at that position. So it's about 168.1. So you can see here this is the 168.2 contour. And if we were to go up a meter, so 0.4, 8, 10. This contour here should be about a meter above the flattish bit of our bowl. So I'll just go ahead and select that contour so you can see it a little bit better. So as I said, this is about 1 meter higher than the bottom of this flattish area, and so it will serve as quite a good extent of our pond. It means that we can keep the bund to a reasonable size. So next thing we need to do is to create a feature that's going to represent our bund. So if you create a new feature class and just name it bund, and it's going to be a line feature. Again, just check that the spatial reference is in whatever spatial reference you would like to work in. Okay, so when you've created your bund, you can simply add it to your map. And then in create, we just need to select our contour that we had before. And in create, what we're going to do is to look at where the natural constriction is, and to simply draw a line which represents the bund across in order to enclose that contour. So just double click to finish and save the edit. Now we'll just select our contour again so we can use it in the next step. So the feature to polygon tool is the one that we're going to use next. So the input features are your bund that you just made and the contour DTM. Now even though we've put in the contour DTM, the only contour that will be used for this tool is the one that's selected, which represents the maximum extent of your pond. So if you call it something like pond, and in the environments again, just check that you're in the right coordinate system and go ahead and run that tool. So you can see what that's done is to take the inputs of the bund and the contour and created a polygon that is the enclosed area. So this will be the extent of your pond. So say we were to build a bund to the height of this contour, then you'd be able to back water up through this whole area, and we can use this to then generate the volume that would be stored as well. Next thing we're going to do is to extract the values of the LiDAR from this polygon area. So to do that, we use extract by mask. And we want to get our values from the original LiDAR, but we only want values that are covered by this pond polygon. So we'll call it DTM pond, and in the environment I want to check that the output raster will snap to our original LiDAR dataset, so we don't get any mismatch in terms of the output rasters. We want to make sure that they're perfectly lined up, so that's what that does. And go ahead and run that. So if I uncheck the pond area, you can see that we've extracted all the values of the LiDAR, but only within the extent of the pond. So if I click on this cell, we can see that the values are the same. The DTM of the pond and the DTM of the LiDAR is the same value, but we don't have a value for around here. Next we can run the surface volume tool. So just use the search again. So we want to use the DTM of the pond as our surface, and this outputs as a text file, so you just need to specify where you want to save it. So we'll save it in this folder. We'll overwrite this one. So you want to choose here the below the pane option, because what we're doing is to put in an imaginary plane at the same height as the top of the pond, and then that will allow us to calculate the volume that lies between that imaginary plane and the surface, which is the base of the pond. So for our plane height, we want to choose the height of our contour that we used as the extent of the pond. So that is 169. That's the contour that we used. So if you input 169 into here, you can leave the Z factor as it is and leave the environments as they are. So run that tool, and you can see that it's popped out as a text file down here. So if you open that table, it's telling us that the volume between that reference plane, which is the maximum height of water in that pond, and the base of the pond is about 72 cubic meters. Okay, so that's the basic premise. You can rerun that workflow on different areas that you think might be of interest and see which ones have the most capacity and which ones are the most appropriate to your project. But that's it for this video, and thanks very much. Bye.